Hello, welcome to another session of the AI Safety Reading Group. Today we'll be discussing consequences of misaligned AI. Now, this paper formalizes, in a way, a certain idea that's been discussed a lot in the AI safety community, the fact that human goals tend to be fairly complex, and if we miss a part of them, that can lead to pretty catastrophic results. This has been discussed in some toy models, informal models, in passing, etc. over the years quite a few times. For example, some work from Chai recently, e.g. the paper When Robots Should Be Obedient, notices that for certain AI designs and types of interactions with humans, if you miss features from your utility function, by features I mean things that you think that are relevant in the world for the AI to take note of and to care about, then that will result in a different sort of behavior from the case where you've included everything that is relevant to the utility function. In fact, they encode a procedure to check for such divergent patterns to see if features are missing, and then to switch the AI off if that is the case. Because otherwise the AI might start being disobedient in strange ways, or it might lose utility for substantial periods of time, or so on. But they didn't really quantify exactly how much utility would be lost. And Stuart Armstrong, for example, explored this from another angle and tried to see what sort of missing features do we usually not include, which would do away with a lot of utility loss. In other words, what are the things that we usually expect utility functions nowadays to miss out on? And he came up with some interesting ideas. I think the right reference here is anthropomorphizing AI. It's a sequence on, that's wrong. But this is the first time that I've seen someone do this particular sort of model. So I think it's worthwhile just for the fact that people can point to this and say, hey, look, if you miss features from your utility function, then you are guaranteed to, in some cases, lose utility. And it's also not too hard to see that you could generalize this in some ways that are fairly desirable, because as it stands, the assumptions in the paper are a bit weird. Anyway, let's just get on to it, right? So how does the paper model things? It says that suppose the world has some parts of it that you care about. For example, you're designing a recommendation algorithm and you care about ad revenue, the quality of your product, the impact you have on society, the diversity of the content you recommend, and you can model these using some numbers. Let's say using 4 numbers for each of those things, right? And you know that no matter what, there are some restrictions on how high these numbers can go. For example, because a person can only click on so many ads at a time, so you can only get so much ad revenue from them. Or because you're sure that you can only show so many different pieces of content in a person's lifetime, right? Like you can only watch so many different shows, given the life you lead on Earth. These are meant to be reflecting some of the assumptions of the paper, where it's assuming that the attributes you care about cap out in some way. That is, the world can't have any more than a certain amount of these attributes. This is somewhat reasonable in that, you can just make the attributes the limit so high that it's essentially irrelevant in your day-to-day affairs. So we won't quibble over that too much. And the particular sort of limit is described by a cost function, where they say that we're going to draw a boundary in the space of attributes and say that everything on one side of this boundary is part of the worlds that are allowed, and everything on the other side is part of the worlds that aren't allowed. Now, of course, you have a utility function over the attributes of the world that you care about. And we assume that in principle, you like just having more of each attribute. So let's say that, again, we're going back to the recommendation algorithm. Obviously, if you get more ad revenue, your utility is always going to go up. If the quality of your product improves, then the utility that you get will improve because you have some pride in creating a well-crafted thing, or so on. Or, for example, obviously, you want your audience to enjoy your creation as much as possible. So they make this assumption that your utility function can only increase with your attributes. As you have more of one of your attributes, your utility goes higher. And that is kind of standard in economics and is applicable to loads of situations. So, it's not too crazy a restriction, right? And even if it isn't the case, even if your utility function does eventually go down in some place, you can say, oh, okay, well, like in those cases, those situations are so rare that they don't really matter, practically speaking, right? For example, say, perhaps for a human, there can be such a thing as too much pleasure, right? But it's very unlikely that you're going to wind up in such a position using the things you have today, unless the AI you are employing is quite powerful, because we all know the standard case of, oh, okay, well, the AI just hooks you up to a system which floods you with endorphins. In that case, too much happiness is probably a bad thing and your utility goes down. But this paper is more dealing with more everyday or current AI. So again, we'll just leave that assumption for now and not really argue against it. So what about the AI? Well, the AI, we're going to say, considers only some of the attributes we care about, but not all of them. This is, of course, pretty much always true, right? Like, say, in the recommendation algorithm system, it is very hard to find out how you can encode the impact of your algorithm on the well-being of the community. That's what features would you use for that? How would you properly encode the well-being of the community in maybe just 2 or 3 numbers? That's a pretty tricky thing to do. As a person designing this algorithm, you're probably just going to skip that and say, forget it, I'll just encode in the utility function the amount of ad revenue I get and the diversity of the content I show, because those are somewhat easy to measure and I can just optimize for that. Surely that's not going to be a problem. Well, so says the paper. Yes, it will, eventually. And now what about the AI's utility function? Well, the utility function now will just be another thing that keeps on increasing with the attributes, but only with the limited set of attributes we've given it, only with our impoverished description of the attributes of the world we care about. In this case, it's only getting 2 out of 4 of the things we care about for a recommendation algorithm. And we're still going to say that, okay, the AI's utility, it increases with the more ads it gets and with the more diverse content it shows. That is going to be true no matter what. So we have the rough setup. Okay, now what is this paper saying is going to happen? We can kind of guess what's going to occur. Because the AI in this recommendation algorithm setup doesn't really care about meaningful interactions or overall community well-being, it's just going to try to drive the world in a state where there are none of those things, presumably. if it comes at the cost of ad revenue or if it comes at the cost of meaningful interactions. And, even otherwise, they might be decreased because, suppose the AI just is doing some random actions which have some complicated side effects, and it doesn't really care about how that impacts community well-being. Well, the AI is going to take it anyway because as long as it has and leads to an increase in ad revenue, then that's good in the AI's mind. And this is sort of what the paper gets at. It says that in this situation where we have our ad system, where we only give the AI 2 attributes to care about, and we say that, okay, ad revenue is restricted in how high it can get, and so is the diversity of content. In that case, it turns out that the AI, it's going to eventually optimize things to a state where some of the attributes we care about wind up at lower value as they possibly can go. This sort of makes sense because our constraints ensure that there's a kind of trade-off between how much community well-being you can have and how much ad revenue you can generate, or say how much content diversity you can have, right? And for the AI, since it only cares about ad revenue and content diversity, it's going to trade away as much community well-being as it can. It doesn't really care about community well-being. As long as it increases its utility even a tiny bit, it's fine. So, it seems pretty natural that the community well-being is just going to be driven down to as low as it can possibly go until lowering it any further doesn't free up any more resources for what the AI cares about. This is what I meant by this being a fairly common result in AI safety, or rather spoken of as if it was a common result. We've all heard these claims before, right? Usually in something like, say, Goodhart's law or that sort of thing, where eventually there's a trade-off that happens between some of the things we talk about and some of the things that we want. Usually there's some kind of trade-off in the limit, and if we optimize for just one of those things, it's going to come at expense at the other things, right? Like, say, again, with the happiness example, if you try to optimize too much for happiness, you're just going to wind up with an AI flooding everyone with endorphins, and you rob everyone of freedom, which is another thing we care about, or, beauty or so forth. And this paper then goes on to say, okay, well, there's a couple of ways you might be able to get around that. You might be able to get around that by saying, we're not going to let the AI reduce any of the other features of the world that we care about. And that, of course, does do something useful, but it doesn't really get you that. It doesn't necessarily get you to the best possible world you could have been in, because the AI might say, okay, you're really limiting me here. I can only, I have to keep community well-being at this level, and I have to keep the quality of the product at this level. So I only have so many resources I can use to generate ad revenue and content diversity. I'm going to try to get as much as I possibly can, but you're restricting me here. I can't do every action I possibly could. So I'm not going to be able to do the best according to my utility function, and conversely, the best according to your utility function. But then there's a kind of strange thing that happens here, which is that I haven't really said that the things you care about have a lower bound, right? Like I've said, for example, community well-being. It might be the case that you exist in some world where it's possible to have ridiculously low levels of community well-being. Perhaps it's even possible to have hell-like levels of community well-being. And what's kind of interesting about this paper is that it says that if the if the constraints that are placed on community well-being, content diversity, etc., if the constraints on the attributes are shaped in a certain way, and if your utility function has a particular sort of shape, which is kind of difficult to describe in words. I really wish I had my slides here. But if they have some particular shapes, using some fairly simple assumptions, then you are going to spend arbitrarily long amounts of time in arbitrarily bad worlds according to your utility function. This is guaranteed to happen. So what I mean by this is that, say, suppose that you have some world which you say is -10 utility. Then the AI is guaranteed to put you into worlds below 10 utility for an infinite amount of time. And suppose you ask, okay, fine, but I really don't want to be below -100 utility. That's just too horrific. Well, too bad. The AI is still going to put you into worlds which have less than -100 utility for an infinite amount of time. And this is going to happen no matter how low the utility is. So things are just going to get more or less worse and worse and worse. Again, these are somewhat strange conditions, but you could see an unwary designer putting something like this into an AI system. Hopefully no one is stupid enough to do that for a super intelligent AI, but who knows, you know? Like there was that case of Stuart Russell telling the designers of Facebook that, look, you guys are saying that you aren't going to input a stupid utility function, but you started off for a few years just trying to get AI to maximize the number of clicks. And, you know, that had pretty weird effects. So if a massively successful company with brilliant engineers like Facebook can do this for a couple of years at a time, well, you know, that's not so good a situation. But at least this paper formalizes this, that it really could get that bad. And it has been accepted in some pretty good journals. So hopefully people will say, oh, okay, if you are doubting what I'm saying, here's a formal argument showing some guarantees. The methods that the paper talks about in order to prevent this kind of thing, they are more or less a sort of interactive game, which the Center for Human Compatible AI, CHAI, likes to use, where the AI does something and the human has the option to update their utility function or give them some information. The AI does another thing and the human repeats. So Soren, if you would mind going to figure 1, scroll up. That has just like a nice little cartoon of what I mean. In this case, what happens is the robot is given a utility function and optimizes it for a little bit. The human looks at them and says, okay, these are I want you to stop now, and I'm going to give you a different utility function using these features. And then the robot starts optimizing that, and it keeps on going on like that forever, or until you hit the perfect mix of attributes of the world and the perfect policy for the AI to follow. And they guarantee that in their particular scenario, the human is guaranteed to eventually wind up in the best possible world according to the utility function. Now, of course, there are a lot of things you can take issue with this. For example, say that, oh, okay, I don't believe that my utility function is always increasing, or with these attributes you talk about. Or, for example, I don't think that there are these constraints that you really speak about. I think that things can be fantastically good, or what have you, which is fair enough. But that's not really the sort of point of this paper. It's more or less just I suppose it's perhaps unfair to say this about the paper, but it seems like it's more like just turning folk wisdom into something sort of more formal and rigorous and being able to show it off to people. That's kind of my opinion of the paper, which is a bit harsh. because honestly, I look at some of their techniques and I think, okay, the issue is that these techniques you're talking about, they discount things like, okay, well, what happens if you, I mean, you're assuming that the human actually knows what attributes they care about, right? Like, we're not really sure what things exactly we care about. We're not sure how we could even hope to put some of these things into a utility function. And it also ignores things like implementation errors or that sort of thing, where you would really want the AI to be trying to do what you want it to do rather than what you encode it to do or what have you. But still, I suppose it had some interesting things, right? Like, Soren, would you mind going down again to the second figure? The infinite, these curves were what I was trying to gesture at. Oh, you missed it.
Yeah.
There you go. So these curves are trying to gesture what I was talking about earlier, where they have the proxy utility, which is the utility function you give to the AI, which doesn't include all the stuff you care about, and your true utility function, which is the yellow thing with the dotted lines on the left, that does include the things you care about. And they go through their setup for a recommendation algorithm, going through, okay, what features should we leave out? And they see that no matter what features they leave out, eventually their proxies will, their AI optimizing their proxy will eventually start causing the true utility to start decreasing. So you see that on the axis it says utility change with time steps on the horizontal axis. What this is basically saying is that at each time step are the utility functions increasing or decreasing? So if they're positive, then you know they're increasing, and that's fine. If they're negative, then they start decreasing. That doesn't mean the utility is negative, just that it's decreasing with each time step now. So you can see that on the left, the proxy utility, the blue line, keeps on increasing. That's just an optimizer doing what it normally does. And the human utility does increase for a while because the proxy tracks it relatively well. But then eventually, once the AI has had enough time to severely optimize things, to put the world into kind of weird states, then the true utility starts declining. Their behavior sort of gets uncoupled. And on the right, you can see that the people in the paper said, okay, we're going to only use 2 attributes from our true utility function and put that into the proxy utility function and see whether or not the utility eventually starts declining in all cases. And of course, in all of the curves, it does start declining because because according to their setups, according to their theorem, eventually all of these utility functions are going to start losing utility because the proxy utility is just throwing away some of the attributes you care about. It's trying to get rid of them in order to have more resources to use for the proxy things. And that puts you into some really bizarre situations, like we've heard of these things before. For example, say you have a AI that is attempting to reach a very high score in a racing game, and it finds one of those strange situations where it can just go around in a circle and keep on increasing in points. And the utility, according to the game, keeps on going up, but you want the robot to be very good at driving. And okay, sure, it knows how to drive pretty well around in circles, but if, for example, you were, I don't know, in that car and you were trying to get somewhere, I'm pretty sure that your utility would start declining after the first hour or so that you go around in circles continually. And, you know, you would get pretty bored eventually. But that's more or less the contents of the paper. I'm very sorry I don't have my slides, and I couldn't have given a better presentation, but I hope we can discuss things. I am, yeah.
Well, thank you very much, Charlie, for your presentation.